So, ngayon ang topic natin is about soil structure. So, we're done with soil texture. So, these are the definitions of soil structure. So, soil structure are, so soil separates are grouped together in the form of aggregates. So, yung mga soil separates natin kanina, just like yung sand, silt, and clay, pag sila ay nag-group together, so they are binded together with other matters, like organic matter, so they form aggregates. So, yung aggregates na yon, when they are arranged together, these are what we call the soil structure. Okay, their defined patterns is what we call the soil structure. So, it refers to the arrangement, It refers to the arrangement of soil particles and their aggregates into certain well-defined patterns. So another definition is it describes the spatial arrangement of particles to complex aggregations, pores, and channels. Sand, silt, and clay and organic particles become aggregated together due to various forces and at different scales to form distinct structural units called Peds or aggregates. So ang tawag natin sa natural aggregates is Peds. Okay? Peds yung tawag sa kanya. Mamaya may ma-encounter tayo na tinatawag na clads, which is different from Peds. So how soil structure is formed? You can see here, this is an individual soil particle. So it can be sand, silt, clay, organic matter, or fertilizer, or other concretions that when grouped together, they form an aggregate. So that aggregate now will be arranged with other aggregates, so that how a structure is formed. So that's the soil structure. So natural aggregates or Peds. There are many types of or shapes of Peds occur in soils, often within different horizons. So karaniwan, ma-observe natin yung different aggregates, their different classification in different horizon. So sa surface, may ibang soil structure. Sa below the surface or yung horizon natin, may another soil structure. Some soils may exhibit a single-grained structural condition, while some soils occur as large, cohesive masses of material and are described as exhibiting as a massive structural condition. So meron tayong mga tinatawag na structureless, but they are also considered as soil structure. Yung ating single-grained or yung ating sand, di ba, once na hinawakan mo yun parang pira-piraso lang. So that's a single-grained structure. Then we also have what we call the massive. So napaka-cohesive niya, wala siyang mga pore spaces. So that considered also as a structureless, which is what we call the massive structural condition. Then there are structures that have different shapes. So these are different in terms of size, shape, and distinctness. So yun yung ating mga structured na tinatawag. So first, before we describe the different types of soil structure, let me discuss first the three kinds of soil aggregates. So yung natural aggregate na tinatawag natin, which is the present in nature without any disturbances, so yun tinatawag nating Ped. But once we incorporate management or disturbances like cultivating the area or cultivating the area, so yung mabubuo nating mga aggregates doon is what we call clads. Okay? Clads are formed as a result of physical disturbance like cultivation or tillage operation. Then another form of aggregates, but it is commonly small, na matatagpuan natin sa soil, these are what we call the concretions. Concretions are also natural aggregates where chemical forces are involved in binding the particles together. So these are commonly a certain element that is nagsama-sama. For or nag-flocculate. So they form a concretion. Like for example, yung ating iron concretion, minsan may makakita tayo sa soil ng mga spots na red, or yun yung mga iron concretions natin. Minsan makikita tayo black concretions naman. These are what we call the manganese concretion. So yun yung mga nagsama-sama or nag-arrange na mga manganese. So they form a concretion. So that's the three kinds of soil aggregates. Now what are the different types of soil structure? So again, soil structure is divided into two. We have the structureless or yung unstructured, and yung ating mga structured na soil. So under structureless, we have what we call the single-grained and the massive. Under the structured, we have spheroidal, which is divided into two. We have the granular and crumb. Then we have the block-like soil structure, which is angular blocky and subangular blocky. Then we also have the prism-like structure, which is divided also into two. We have prismatic and columnar. Then we have also platelike or yung platy natin. Then other soil structure, we have what we call the wedge and lenticular. So yung unstructured natin, which has no formal organization or structure. This includes single-grained structural condition and massive structural conditions. So single-grained structural conditions is non-coherent or unaggregated. So hindi sila sama-sama yung structure niya, kaya structureless. Like yung sand sa beach, di ba? They are structureless or they are single-grained. This condition occurs in soils with high percentage of sands or gravels consisting of loose individual particles that lack cohesion. Lack cohesion or lack the attraction between the particles. Hindi nagdidikit-dikit. Where the individual soil particles show no tendency to cling together. Then the massive structural conditions are united as or forming a whole. So isa siyang malaking structure. Okay? There is no arrangement of soil particles into real structural units. So wala siyang subunits. It is just a massive structural condition. This soil condition usually has topsoil structures that have been destroyed by excessive tillage and compaction, and are often found deep in the soil that are cemented together. So karaniwan, once na yung soil natin is laging nako-cultivate, then nagkaroon ng compaction or dinaanan ng machineries. Okay, nasiksik na wala yung pore spaces. So doon na po-form yung ating massive structure. So ito yung tsura ng single-grained and also ng ating massive structure. So structured, these are soil beds are classified based on shape. Sa yung shape na na-form ng Peds or shape ng Peds, doon natin kinaklasify yung uri ng structure natin, pagka-structured. The four basic structural types are spheroid, platelike, bloklike, and prismlike. These shapes gives rise to granular, platy, blocky, and prismatic types of structure. A soil aggregate is a group of primary soil particles that adhere to one another more strongly than the surrounding soil particles. So, the spheroidal structure is formed where there is abundant organic matter and biological activity. So, it is commonly found on the surface horizon. A stable, granular structure with plenty of organic matter is usually favorable for plant growth because of macropores between and within Peds, providing for a good seedbed and easy passage of water, air, and roots. Such a condition is associated with good tilth. So, one of the best soil structure that we can have in soil is what we call the spheroidal. Okay? Spheroidal can be granular or crumb. So, granular is a larger structure compared to crumb. Okay, granular is commonly the size and look of grapefruit, grape nuts. They are bounded by curved or very irregular pieces that are not cast off adjoining Peds. So hiwa-hiwalay yung structure niya. Then crumb is very porous spheroidal structure. So here, as you can see here, are the structure granular or crumb. So wala silang ganong pinagkaiba because it is considered, both of them are considered best pagdating sa agriculture natin. Okay, lalo na sa mga uplands. Kasi kailangan talaga ng yung makapag-penetrate doon yung roots. Diba? Sa lowlands kasi karaniwan sa rice paddy, yung ang kailangan nating structure doon is karaniwan more on clay or pinapadal natin siya, winawasak natin structure. Karaniwan sa mga vegetable farm, so given na maganda yung structure doon kapag granular or crumb. Okay? Then bloklike. These are polyhedral in shape and approximately the same size in all dimensions or equidimensional. Ped pieces accommodate each other, fitting together like puzzle pieces with intervening planar pores. The blocky structure forms mainly by repeated shrinking and swelling of clay as it dries and wets. Blocky structure occurs in several kinds of horizon but is most prevalent in subsurface horizon. So karaniwan sa subsurface horizon na nakikita yung block-like structure. So block-like structure is divided into two. We have the angular blocky. Structure is a polyhedral aggregate with faces intersect at relatively sharp angles. So yung edges na is sharp compared to that subangular blocky, which is yung corners ng subangular blocky is commonly rounded. So subangular blocky structure is polyhedral aggregate with faces that are a mixture of rounded and plain faces, and the corners are mostly rounded. So as you can see here, these are the angular blocky. So yung edge na kung makikita nyo, they are sharp compared of the subangular blocky, which is more rounded. Okay? So in a profile, you can see here the angular blocky and the subangular blocky. So dot cracks are commonly formed because of the shrink and swell property of clay. So shrink and swell, once nag-absorb ng water yung soil natin, they are swelling, di ba? Then pag na-dry naman yung soil natin, they are shrinking or lumiliit. So pagka lumiit, so may iwan doon yung mga spaces na yan. So that's how the different Peds is observed sa mga spaces na yun na na-form. Then we have the prismlike, bounded by flat, rounded vertical pieces that vary in size. They are also often associated with swelling types of clays. So these are elongated structure. So vertically, yun yung parang division nila. Medyo mahaba. What's the difference between prismatic and columnar is their tops. Okay, yung top part nila. So prismatic have what we call the flat tops. Okay, yung flat sila. Peds are vertically oriented, pillar-shaped, with accommodation between adjoining pieces, most commonly in clayey soils with strong shrinking and swelling, and older soils with well-developed horizons of clay accumulation. This structure commonly occurs in subsurface horizon in arid and semi-arid regions, and when well-developed provides a very striking feature of the profile. Columnar, on the other hand, Peds are also long in the vertical dimension but with the rounded or cup-like tops. Okay? Most common in clay horizon, which are high in exchangeable sodium. So how we in soil profiling, how we note high exchangeable sodium is by putting small letter N. I hope you can review also this one. So B means a subsurface horizon. Then T is the accumulation of argillic clay. Then N is the accumulation of exchangeable sodium. So that's how we note in soil profiling. The rounded top may be produced by upward swelling of the beds and or by dispersion of clay as the sodic soil is wetted from above. So a sodic soil is commonly wetted from above. So that's how then it shrinks and swell. That's how na-form yung cup-like top. Okay, sa mga rich in exchangeable sodium soil. These are the pictures of columnar, makikita natin, round tops, and also the prismatic, which is flat yung tops niya. We have the platelike or Platy. Beds are thin, flat, and horizontally layered. It commonly occurs in a horizon, light-colored, elevated horizons that underlie some a horizon. It may also be inherited from soil parent materials, especially those laid down by water or ice. In some cases, the compaction of clay soils by heavy machinery can create a platy structure. So ito yung karaniwan makikita natin sa paddy soils. Di ba, yung paddy soils kasi once na kinocultivate natin yon or pinapad natin, nag-undergo ng paddling, yung surface lang yung ating dinidisturb. So naka-compact yung below the surface, which is the commonly below a horizon. So nagpo-form siya ng parang plate-like structure na pahaba. So karaniwan, ito yung this is the structure that is most or pinaka-less permeable. Pag sinabi natin permeability, ito yung pagdaan ng water or ng air dun sa medium. So hindi siya na nape-penetrate yung plate-like structure. Yun yung pinaka hindrance doon. Like for example, once na nagtanim tayo, like for example ng fruit trees, okay? Then may yung structure na pala ay platy. So karaniwan, yung root, may root impedance doon or hindi makaka-penetrate doon yung root. Kaya once na dumating yung bagyo, karaniwan yung mga puno natin is natutumba kasi hindi maganda yung pagka-penetrate ng roots nila doon sa lupa because of the structure of the soil. So next is we have the wedge. The wedge soil structure has a shape similar to block-like, that of a football. It is a elliptical interlocking lenses that terminate in acute angles, bounded by slickened sides. Similar to block-like aggregates, these are horizontal-oriented, found in subsurface horizon, and occurs in soil that have high amount of shrink swell place. So, slickened sides, makikita nyo, may parang mga guhit-guhit dyan sa soil structure. That is what we call the slickened sides. So, these are the product of shrink and swelling of clays. Once na nag-shrink and swell yung clays, yung pagitan ng dalawang aggregate is nagkakaroon ng parang paggasgas or interact nilang dalawa. So, doon na po-form yung slickened sides. Okay? So, yung slickened sides na yon that can be used to identify yung wedge natin. These are the structure of wedge. Then yung surface ng wedge natin, yung wedge Peds natin has a presence of slickened sides, tinatawag. Then we have the lenticulars that are similar to Platy structure. It is a horizontally layered structure that is recognized for plates that are thickest in the middle and thin toward the edges. So compared to Platy structure, yung Platy kasi parang plate lang siya, flat. Okay? When we say lenticulars, yung middle part niya ay thick. Okay, that's the difference between lenticulars and platelike. The lenticular structure is commonly associated with moist soils, texture classes high in silt or very fine sand, that's like silt loam, and a high potential for frost action. So, sa lahat ng nabanggit na structure, what is the most desirable soil structure for most of the crops? Siyempre, yung soil structure is depend pa rin dun sa ating itatanim. Okay? Like yun nga, like sa rice. Di ba? Pag sa rice kasi, sa upland, kailangan talaga sinisi-rice structure. Pinapaddle. Kasi kailangan submerge yung lupa. But in most cases, what we desire soil structure is the granular or crumb. Why? Because their aggregates are porous and more or less rounded. It contains proper amount of micro and macropores. So micropores exist within the individual aggregates and are responsible for water retention. So, sa single aggregates, yung mga pore spaces doon is what we call the macropores. Karaniwan doon na i-store yung water. Then between soil aggregates is what we call the macropores. These are larger pores and are found between the aggregates, which are good for aeration of the soil and beneficial for plant roots. Okay, ito naman yung mga macropores naman yun naman yung na-form between aggregates. Okay, when we say micropores, these are within aggregates, and when we say macropores, these are between aggregates. Okay. Then granular or crumb has a low bulk density. Low bulk density means in a specific volume, mas madami yung air niya kaysa sa solid particles. That's low bulk density. It has an appreciable number of large pores, and the presence of water is stable aggregates. So these are the hierarchical organization of aggregates. So we have what we call the microaggregates. So kung makikita nyo, itong each individual of that is composed of microaggregates. So ito yung mga microaggregates natin. So that form, pag nagsama siya may mga microaggregates, yan yung tinatawag nating macroaggregate. Macroaggregate then, it forms a soil structure. Okay? So another classification, another hierarchical organization of aggregates. First is, we have what we call the primary particles of silt, clay, and humus. So you can see here the individual particles of silt, then clay and humus. Then we have the organic matter. So they are the primary particles. Then that primary particles, when they are combined together, they form what we call the sub-microaggregate. These are mineral grains encrusted with plant and microbial debris. Plant debris coated with clay. So ito yung ating sub-microaggregate. Then sub-microaggregate, when they are combined together, they form what we call the microaggregate. So ito yung mga microaggregate natin. So microaggregate contains of root hairs, hyphae, and polysaccharides. So it ranges from 0.3 millimeter in size. Then composed of microaggregates is what we call the macroaggregates. So ito na yung macroaggregates natin na nagpo-form ng structure. So, is the definition of macroaggregates. So, surface horizons are usually characterized by a roundish granular structure that exhibit a hierarchical in which relative large macroaggregates ranges from 0.25 to 5 millimeter in diameter. Macroaggregates are composed of many microaggregates bound together mainly by a kind of sticky network formed from fungal hyphae and fine roots. So ito yung mga nagsisilbing binding agents sa macroaggregates. So below that, we have what we call the microaggregates. These are composed of smaller aggregates called microaggregates, which the size is ranging from 2 to 250 micrometer. A microaggregate consisting mainly of fine sand grains and small clumps of silt grains, clay, and organic debris bound together by root hairs, fungal hyphae, and microbial gums. Then that microaggregates is composed of sub-microaggregates. Then sub-microaggregates is composed of those primary particles. So how soil structure is formed? So from these soil particles, we have what we call the process of flocculation. So flocculation are binded with the cementing agent. So after flocculation, meron na tayong tinatawag na microaggregate. Then yung microaggregate, in the process of aggregation, they form a structure. Okay? So yung internal porosity na tinatawag natin or yung microporosity, ito yung within that aggregate. So etong aggregate na to, yung mga spaces between that is what we call the internal porosity. So flocculation and dispersion. So what's the difference between the two? So as you can see here, we have the calcium as cementing agent. Yung clay, makikita natin yung clay. We all know that clay is a negative charge dominantly, di ba? It composed of aluminum octahedron and silica tetrahedron. Then due to some cases, so it forms negative charge. So that negative charge can be can attract positive charge, which example is calcium. So calcium is a good flocculating agent. So pinagdidikit niya itong dalawang clay. So that's flocculation. Wherein, meron naman tayong mga less flocculating ability nutrients natin like sodium. So yung clay natin, which is negative, is mag-absorb, magdidikit ng sodium. Yung sodium na yon ay hindi na pwedeng dumikit pa sa another because of the charge, di ba? Sodium is only positive one. So that will cause dispersion. Yun yung tinatawag nating dispersion. Okay, that's the difference between flocculation and dispersion. So what are the other flocculating agents? So we can also use, aside from lime or calcium carbonate, organic matters are good flocculating agents, and also aluminum and iron hydroxides. So yun ay mababasa nyo dito. So basahin natin to. So aggregation begins with the flocculation of clay particles into microscopic clumps or flocules. If two clay platelets come close enough to each other, cations compressed in a layer between them will attract the negative charges on both platelets, thus serving as bridges to hold the platelets together. So platelets ang tawag natin dito. Itong isang clay na to, one platelet, then another platelet. So they are binded together by a flocculating agents. These processes lead to the formation of small stack of parallel clay platelets, termed as clay domain. Other types of clay domains are more random in orientation, resembling a house of cards. These form when the positive charges on the edge of clay platelets attract the negative charge on the flatter surfaces. So multivalent cations, so ito yung ating mga cementing agents. So calcium, iron, and aluminum also complex with hydrophobic organic molecules, allowing them to bind to clay particles. So that's flocculation. On the other hand, the dispersion, when certain cations, especially sodium, but to lesser degree potassium and even magnesium, with less flocculating ability than calcium or aluminum are prominent, the attractive forces are not able to overcome the natural repulsion of one negatively charged clay platelet by another. So magkakaroon ng repulsion. So yung sodium positive na nasa edge nito at yung sodium positive na nasa edge din nito, magre-repel sila to each other. Okay? As we all know that same charges repel to each other. This is called dispersion, where the clay platelets cannot approach close enough to flocculate, so remain dispersed and cause the soil to become gel-like, impervious to water and air, and very undesirable from the standpoint of plant growth. This dispersed condition is most dramatically stimulated by sodium ions and is most common on soils of arid and semi-arid regions. So dahil high in sodium, yung karaniwan, yung ating sodic soils na tinatawag, they are very dispersed because of the sodium. And what are the different factors affecting aggregation? So we have climate. So climate, alternate wetting and drying due to rainfall causes the soil to expand and contract, allowing the particles to group or orient themselves into aggregates. So again, di ba yung sa climate, when there is rainfall, magiging hydrated yung soil natin. So tendency, it will swell. Okay? Pag nag-absorb ng water, yung soil natin, it swells. Then after na magkaroon ng, like for example, uminit, so made-dehydrate yung soil natin, it will shrink. So that shrink and swell process will leave a space, yung pore spaces. So yung pore spaces na yun, yung naghahati sa ating mga aggregates. So that's how it affects the formation of aggregates, yung ating climate. Then vegetation. Aside from the effect of organic matter on aggregation, so of course, organic matter is one of the cementing agents sa ating aggregation. The physical effect of plant roots assist in the process of aggregation, aggregate formation. So, like for example, yung roots natin, they penetrate, so they leave a spaces, so that affects the aggregation of the soil. Also, microbial activity. Microorganisms excrete substances as byproduct of metabolism, and this very useful as cementing materials. Fungi and other filamentous organisms produce mucilaginous substances for aggregate formation. So yung ating mga microorganism, they secrete specific substances that can contribute to the aggregation of the soil. Then, what are the implications of desirable and undesirable structure? So first, we have the desirable structural condition. It is one with high proportion of medium-sized particles and low bulk density and an appreciable large amount of large force. So first is high proportion of medium-sized particles. So yung ating desirable soil structure, dapat medium-sized lang yung kanyang particles, like yung meron tayo sa crumb or yung sa granular natin. So it has also low bulk density. Dapat may pore spaces yung soil natin. Dapat hindi compacted. And also large amount of large force. So it implies that it is highly permeable to water. So in desirable structure, yung water natin ay freely mapepenetrate ng water. So it is permeable to water. Have satisfactory water infiltration and retaining capacities. Dapat nag-i-infiltrate yung water doon, hindi nagkakaroon ng runoff. So that's a desirable structure. Readily penetrated by plant roots, so that the roots can easily penetrate. So there is no root impedance na nagaganap. Then resist compaction of farm implements. Dapat even though yan ay daanan ng mga mabibigat na machine or farm implements, kaya niyang ma-resist yung compaction. Dapat bumabalik siya sa dati niyang structure. So that's the desirable structural condition. Then we have the undesirable structure with high bulk density. Pag high bulk density, it means that there are more solids than the pore spaces in total. Okay, in total volume. Ito yung tinatawag natin compacted na lupa pag high bulk density. A few large pores and low content of water, or low content of water stable aggregates. It implies that permeability of air and water is low. So hindi nakaka-penetrate doon yung air and water, or it's very slow yung movement ng water within the soil. So it has an undesirable structure. There is a resistance to root extension. So yung mga roots natin hindi nakakapag-extend because of the structure of the soil. And there is an anaerobic condition prevail. So anaerobic, ibig sabihin the oxygen is limited within the soil. So effects of soil structure deterioration. So it can lead to the reduction of volume of macropores, decrease in porosity, higher bulk density or compaction, greater root impedance or poor root growth, lower amount of available water, and also poor drainage and aeration. So also soil structure really affects the different soil properties. Indicator of soil structure deterioration. How we can say that our soil structure is deteriorating. So first is increasing bulk density value. So tumataas yung bulk density. Ibig sabihin, dumadami or kumokompact yung soil natin. Okay? Per specific volume, dumadami yung solid particles. Nawawala yung mga pore spaces. Then declining organic matter content. absence of earthworm and other soil organisms. So because the organisms can hardly penetrate the soil, so there is a decrease in number of soil organisms. Then claddy soil when tilled or for fine texture soil, and higher soil erosion. So that's the indicator of soil structure deterioration. Importance of soil structure to plants. So erosion and erodibility. Pagka yung structure natin is hindi maganda, like for example, sa upland, okay? Winasok natin structure. So that can lead to erosion and yung losses of surface soil. Then infiltration. Okay? If our soil is very or flaky or blocky, so they have low infiltration capacity or hindi pumapasok dun yung water. Okay? There is a chance of runoff. Mawawala din yung mga nutrients sa surface ng soil. Aeration also. Root penetration, water holding capacity, and also mechanical strength. So how we maintain the soil structure of the soil and how we manage soil structure. First is increase soil organic matter accumulation. Okay? So compared to soil texture, yung organic matter may malaki siyang magagawa sa soil structure. Yung soil texture kasi kahit nalagyan natin ng organic matter, it can change. Okay? But in terms of soil structure, pag naglagay tayo ng organic matter doon, there is a chance na mas maging maganda yung structure ng lupa natin. Then utilization of soil residue as of mulch. Then cover cropping or crop rotation, green manuring, and multiple cropping. So di ba once na yung soil natin is bare, okay, bare soil tayo, walang cover crop sa ibabaw. So yung rain natin is karaniwan directly nagpe-penetrate sa soil. So that destructs the soil structure, then it will swell and shrink, then that leads to erosion. So kaya mas maganda tayong may cover crops and crop rotation. Appropriate tillage, minimum or zero tillage. So sa soil conservation, it is very important or very familiar yung paggamit ng minimum or zero tillage. Kung saan lang tayo magtatanim, dun lang tayo magdi-destruct ng soil structure. Then soil conservation practices. Like yung proper contouring pagka sa mga elevated areas ka, so that will helps the maintenance of good soil structure. So paddling, so this is very common, specifically here in lowland. So refers to the destruction of soil aggregates into primary particles at or near moisture saturation. So degree of paddling depends on soil moisture, of course. So we need to in order to properly pad the soil, there is the soil moisture must be saturated. Or dapat yung micro and macropores niya ay may tubig. Then it depends on soil texture and soil structure also. Nature of the implement used and the intensity or the actual operation. What are the advantages and disadvantages of paddling? So advantages is of transplanting with control, moisture conservation, improvement in the availability of plant nutrients due to soil reduced condition. Then disadvantages involves a great amount of energy and time, high water requirements, problem of soil structure regeneration. So once kasi na nagpaddling ka, masisira na yung structure ng soil. So the structure regeneration is very problematic in terms of paddling. Then development of flow pan or yung hard pan natin na tinatawag. So that's the end of soil structure